In this short lesson, this is actually part of section 1.2 in your Algebra 2 textbook. And so we're going to discuss using linear regression to find the line of best fit. And so we'll start on page 20 of your Algebra 2 text, and we're going to input this data. We'll put these numbers in for X and these numbers in for Y, and try to find a line of best fit and see what the scatter plot looks like. And so on your TI, if you have a TI-83 or any of the TI-84 models, then the instructions I'm going to give you here will work. If you have a TI Inspire, then I posted separate directions. You can still watch this video, but some of the steps are a little bit different. So if you go to my course handouts website for Unit 1 in the Algebra 2 text, there's also a link on my assignment listing to show you how to do this if you have a TI Inspire, because the steps are a little bit different. But again, these steps will work. What I'm going to show you right now will work on any TI-83 or TI-84. So we're going to start at the Stat menu and go to Edit. Your List 1 and List 2 may be empty, or they may have numbers in them. So if you have maybe some numbers in there from previous data that you've entered, you can clear the data by going to the moving your cursor up to the title. Do not press delete, because that will remove the title. You want to press clear, enter, and that clears all your data. So I'm going to go to list 1 and press clear, enter to clear all the data. So now list 1 and list 2 are empty, and I'm going to put all my X values in list 1. So I'm going to type 117, 128, and so on, putting in all the X values. Every time you press return or enter, it'll go down to the next row. And then put all your Y values in L2. Now I may be going through these steps kind of quickly, so feel free to pause the video at any point if you need to catch up on entering the data or anything like that. So when you're once you have all your data there, then first thing we want to do is look at the data and see, does it even look like it's linear? Does it look like there might be a line that comes close to going through that data? So to graph the data, first we'll go to stat plot. So that's right above the Y equals menu. So second function, stat plot. And you want to make sure plot 1 is on. So I'm going to press enter, and so plot 1, I'm going to turn that on. And then the type of graph, it's scatter plot is what we want. That's what it's already on. And it's showing that it's getting its X values from list 1 and its Y values from list 2. And you can choose any of these different types of marks. The square seems to work pretty well, but you can change that to anything you want. And so that's ready to go. Now I need to go to Window. And look at, if you look at our data, look at our X values. They're all in the 100 range, so we might want to make our X values go from 100 up to 200. All of our X values are within those two numbers. And then our Y values, looks like we could go from 20 to 60. We could even go from 0 to 60. Any range that includes those will work fine. So I just noticed I typed that in the wrong spot. So I'm going to make my X scale 10. My Y min is what I want to be 0. And my Y max, I'm going to put 60. 0 to 60 should be fine. All my Y values are in between those two numbers. And then if we press graph, there's our data. Now it does look, especially at the beginning, looks very linear. There's a couple points here that are a little bit off the line, but we could imagine a line going somewhere through the middle of that data. Okay, so now we're going to let the calculator program find the line of best fit for us. And the way we do that, we go back to stat, and this time we're going to go over to the calculate menu, the second menu over to the right, and we're going to look for linear regression. So on my calculator, it's option 4. There's also option 8 is linear regression. Either one will work. It doesn't matter which one you use. You just have to pay attention to which parameter is A and which one is B. So if I choose option 4 here, A is going to be my slope, B is going to be my y-intercept. If you think of the form y equals mx plus b, the number in front of x is your slope. So I choose linear regression, press enter, and here's where if you have a TI-83, things might be a little bit different. I'll show you how to type that in, but if you have a TI-84, you should see something like this. It's accepting list 1 and list 2 for the x values and y values. Frequency list, you don't need to put anything there. And then this is important, store the regression equation. This can save us some time and some accuracy if we store the regression equation. You don't have to do this, but it will make it a lot easier to graph. And so we want to store whatever regression equation we get, we want to store it as y1 so that we can graph it and see how well it fits our data. And so to get y1 here, these steps go like this. So under vars, that's for variables. So we want to find the y variable. So I'm going to press vars, then go over to y vars, function, y1. And now it's going to store the regression equation as y1. We have everything ready to go, and now I'm going to calculate. Now keep in mind, if you have an older calculator that doesn't look like this when you clicked linear regression, then I'll show you what you're going to type in to do the same thing. Okay, so there's our regression equation. It's saying our slope is about 0.33, our y-intercept is about -11, and notice that if I press y equals, it already typed it in for me. So it's already there. There's our big long slope, and there's our x, and there's our y-intercept. Okay, and when I graph it, that line does look like it fits the data pretty well. So if you have an older calculator, if your screen, when you chose linear regression, if your screen didn't look like that, then here's what you're going to type. You press linear regression, and then you have to press linear regression again, or actually you're gonna have lin reg, and then after that in parentheses we want to put in list 1, comma, list 2, comma, y1. And I'll show you where to get list 1 and list 2. And I already showed you where to get y1, but I'll show you one more time. So that's going to, what this means by putting these in parentheses, it's going to take our x values from list 1, our y values from list 2, and it's going to store the regression equation as y1. And so if you have a TI-83 or even an older TI-84, you want to, right after the word linreg, you want to type this in parentheses, L1, comma, L2, comma, Y1. And so back on the calculator screen, list 1, you will see is down here. Hopefully you can see my cursor. It's right above the number 1. So there's L1. L2 is here, and Y1 was, remember, under variables, Y variables, function, Y1. And so we're getting our list from list 1, our x from list 1, and so on. Okay, so this is what you're going to type on your calculator screen. When you choose linear regression, this will automatically be typed, and then you just have to put the parentheses L1, comma, L2, comma, Y1, and it will give you the same answer, same regression equation, and it'll also store the equation there in Y1. So then again, remember, if we graph it, we see our data, we see our line of best fit, and we see that that was a pretty good job. And our equation, if we wanted to write that down, was y equals about 0.33x minus, let's see, what was our y-intercept? It was about -11, I believe. Saying -11.3. Okay, so that is our approximate regression equation. If you have your textbook here, if you go to the next page, you'll see that they got the same slope and y-intercept here that we got. and their graph here looks the same as our graph as well. Okay, so that's how linear regression works. Now I'm going to go ahead and have you try the next one. So we're going to put these in as our x values, these in as our y values. So go ahead and press pause on your video and see if you can go through all of those steps again on your own, and then press play when you're ready to see what I got. Okay, so to enter the new data, we go back to Stat, Edit, and I'm going to highlight List 1, the title, and press Clear Enter. List 2, Clear Enter. And for my x values, I'm going to put in 30, 40, 50, 60, and 70. It looks like I mistyped those first ones. I'll fix those. 30, 40, 50. Okay, now it looks like I have those all correct. And then the matching y values, 34, 33.5, 31.5, 29, and 27.5. Okay, so once you have the data in, then you go to Stat, Calc, Linear Regression, so option 4. And I again want to store the regression equation as y1, so we'll go to vars, y-vars, function y1, and calculate. So it gives me my slope is about negative 0.175, and my y-intercept is about 39.85. And we can also look at the graph. Looking at the data, let's set our window up first. So our x values go from 30 to 70. So I'm just going to say 0 to 70. And our y values range from 0 to 40. And so now when we graph, we should see our data and our line of best fit. And then so for our viewing window, we did 0 to 80 for x and 0 to 40 for y. I did 0 to 70, but I'll change that to 0 to 80. And that way we see all 5 points. Okay, and again, it filled in the equation y equals negative 0.175 plus 39.85. There's our regression equation. Okay, so that answer we can actually put here. Okay. And another thing that you can do on your calculator to see how well the line fits the data, there's something called an R value, which tells you how well the data fits the line of best fit. And so if we go to catalog, second catalog, and what we're looking for is diagnostics on. So if you scroll down your list, You can get there quickly if you go to alpha D. Oops, let's try that again. Catalog D. You don't need to press the alpha button because it's already in alpha. So we're looking for diagnostics on. And there it is, diagnostics on, enter, enter. And that's done. And so now if I do the linear regression again, follow the same exact steps, I've already got the data in there, so I don't need to enter the data again. And then we already have it stored. So stat, calc, option 4. And so notice it gives me the same slope and y-intercept, but it also gives me this r value. R equals negative 0.98. So when r is close to 1 or negative 1, that tells you that the data fits the line really well, or the line fits the data very well. So negative 0.98 is very close to negative 1. So that tells us that it's a line with a negative slope, and it fits the data very well. Negative 0.98 is pretty close to negative 1. And so anything close to 1 or negative 1 is a very strong fit. And then when you see data that doesn't look like it's very linear, you'll see your R value get much smaller. Okay, now that we have the regression equation, we can answer questions like this one in step 4, predict the gas mileage of the car at a speed of 20 miles per hour. So that means X is 20, and we want to find the gas mileage, which is the Y value. So you would do Y equals negative 0.175 times 20 plus 39.85. So that would be negative 0.175 times 20 plus 39.85, and we get 36.35 miles per gallon. You can also, since we have the function already typed in to y equals, another way to get this is to, on your home screen, go to variables, y variables, function y1. And so we're taking the function y1 and we want to plug in 20. And so this is just like function notation, f of x, this is y1 of 20. When we plug that in, we get the same answer, 36.35 miles per gallon. Okay, so back to your textbook. If you have that textbook, you can refer to this. If you don't have your textbook, you can just look at the video to get your data. So this is our last example of linear regression. So go ahead and enter the days as your x values, the hits as your y values, and see if you can find your line of best fit. Pause your video and press play when you're ready to see the solution. All right, so I have all the data entered, and I'll press stat, calc, linear regression, store the regression equation as y1, and then calculate. So we have a slope of about 2.4 and a y-intercept of about 11.2. Y equals 2.4x plus 11.2. Okay, so there's our regression equation. And to see it, window, our x values go from 1 to 14, so I'm going to go 0 to 15 so we can see all those points. And then the y values, they range from 0 up to, our biggest one is 50, so I'm going to go 0 to 60 for the y values. and then graph. So there's our data, there's our line. This data isn't a great fit. You may have noticed with the R value, which is called the correlation coefficient. If I do this again, R is 0.79. So it is a positive relationship, which means it's going to have a positive slope, but 0.79 is not extremely strong. Last time we had negative 0.98. That was a very strong relationship, but 0.79 is somewhat close to 1, but it's really not really close to 1. So it's a decent fit, but not a great fit, and that's what we see in the graph. We see our points kind of scattered all over the place, somewhat in a linear fashion, but they're not very tightly placed along the line. Now that we have the regression equation, we can answer the question that they were asking here. It says, predict how many hits there will be on day 15. So now we can plug 15 into this equation. Y equals 2.4 times 15. So we're using an x value of 15. Imagine this table went on one number further. What would the y value be? And so we can use this linear function that we got to find the value. And so I'll show you how to get this two different ways. So we can just go back to our home screen on our calculator and do 2.4 times 15 plus 11.2 is about 47.2. So we'll say about 47.2 hits. Or about 47 hits. Okay, so we kind of did that manually here, but you could also, since we have the function already entered in y1, another way to do that is on your home screen. If you go to vars, yvars, function y1, we can say we want to evaluate the function y1 at 15. And so it's going to plug that in for us and give us an answer close to the one we got, but it's actually more precise because look at all the decimals that it's using. We're not rounding to just 2.4 and we're not rounding just to 11.2. And so when you actually plug in 15 into this more precise function, you get an answer of 47.35. So in this case, we're just rounding to the nearest whole number, so it doesn't really matter. But if you were looking for an answer that was more precise, we actually get 47.35 hits using the regression equation that was stored in our calculator.